All right, here we go. This is a bonus for you all. This is part of 36 law of sines. Okay. There's a special case where we have a side, and an angle. Okay. And when this happens, some weird things can happen. Okay. So we have a side, and then outside of it is an angle. And we call this the ambiguous case. Because when we give you a side, and an angle, we aren't always sure how many solutions we're going to get, right? There's two different ways we can get one solution. There's a chance we get two solutions, and there's a chance that it doesn't even work at all. Okay. So we may play with this in class, we may just skip it. I don't know. But here's the basic idea. If we know this side length, right? Um, let's see. Oh, we know an angle. Okay, so here's how I do it. So let's say this is the ground, right? And we know that this angle is, let's say, 40 degrees. Okay. And we know this is a 10-foot long piece of, I don't know, plywood or something like that, right? Depending on the size of this one that's kind of hanging down, it may or may not reach the ground. Okay, so imagine that. So this is the ground, right? Um, well, let's make this 30 degrees, I think. Is that nicer? I don't remember. I don't remember. Anyways, we'll just do this, right? So um, there's a chance that it's the exact right length to just hit the ground and be a 90 degree. Okay. So that's the very first option. If that's true, if this length is exactly the right length, that it just barely touches the ground like this, right? Because this is off the ground. It has to be 40. This is 10. So it's just kind of stuck there. It's stuck like this. And we can kind of have a hinge here. And if that piece of wood that's coming down exactly hits the ground, it's making a 90-degree angle. We're going to get only one solution. Okay. So that's one way to do one solution. Another way to do one solution is, let's say I had this side was 20. The only place it could go would be all the way over here, right? So if this one's so big, there would be only one place where it could go, right? We call that A is greater than B, right? So if this is larger than this, right, it can't go here or here or here. It's got to go here, out this way. So that's the second way. That's the way we can get one solution. So either a 90 degree, or this is just so large that it's got to be all the way out here. And this would be our triangle. Cool. Notice we don't know this side yet, right? We only have side, side, angle, right? That's it. The way we get two solutions is if this length, this board that's coming off this angle right here, right, that we can kind of angle anyways, if it's in between this distance and this distance. So if it's somewhere in between, let's say it was about this long, we could come here, or we could hinge it and it could come here. Either way, it could make a triangle here or a triangle here, right? Right. All right. The final thing is to get zero solutions is if it's not long enough to even hit the ground. So if this was 2 feet long, right, and we raised this up 40 degrees, and this was 10 feet, and this was only 2 feet long, it'd be dangling in the air. It wouldn't come down and reach this other side, which it needs to. Okay. And that's if it's too small. Okay. So those are the four different ways that things can happen. Okay. So we're going to play with that and kind of show you each of them here. And then we'll solve one. I think this will be a solve that ends up being a two solution one. Okay. But just to give you an idea of that this can happen. Okay. So if B equals H, we've got our B and our A. And here we go. So this is along the ground. We know we're going up 30 degrees. We know our B is 4 and our A is 2. And this works because this is a 30, 60, 90 triangle, right? And sine of 30 degrees is opposite over hypotenuse, 2 over 4, which is 1/2. Okay, so in this case, we've got this locked in, we've got the 4 locked in, we've got the 2 locked in. It's going to come here, and that's going to make exactly a perfect right triangle. Okay, all right. If A is greater than B, so if this side is greater than this, we're going to get that situation where it's too far out this way, right? So here's the ground, right? We raise this up 30 degrees. We say this is 4, and then, oops, sorry, right? This is 30 degrees. This is 4, but the other side is going to be 5, so it's bigger, right? It's this big. The only place we can put that is if we head out this way. Okay, so if we put a 5 out there, now we have exactly one solution. It's the only place it can go. All right. If my third side, or that side, the dangling side, is too small, we get 0 solutions, right? So let's look at this, right? A is equal to 30 degrees, so we do 30. My B is equal to 4, right? But my A is only 1.5, so it's only going to go to about here, 1.5. It's too small. No matter how I hinge it, it's never going to reach the ground here. Okay, so poor little guy's never going to become a triangle. So sad, so sad. All right. If my A, that dangling side, is in between this height, right? The height of a right triangle, which would be 2, we see that over there, right? If it's in between that and the side length here, we're going to get 2 solutions. And this is where it gets really fun. Okay. So if we have 30 degrees going here, 30 degrees, and this is 4 and this is 3, we're going to have a situation where the height is 2, but 3 would go here, or 3 would go here. Okay, we actually end up with 2 different triangles. We'd have this triangle, right? The 4, the 3, and the 30, right? We'd have this bigger triangle with the 4, oops, that's not very good. The 4, the 3, and the 30 looking like this, right? So we're going to have those as our options. Pretty crazy, right? Kind of crazy. So we're going to solve this, okay, in a second. I don't know if I'm taking a break or not. I don't know what time lunch is. It might be now. I may have to pause halfway in between this. So we'll go for it. Let's see what happens. Oops. Oh no! I'm pausing now. Okay, I think we're going for it. All right, so we're going to use law of sines here, right? So I'm going to go sine of 20 degrees over A, which is 3, is equal to sine of angle B over 5, right? We're going to do some cross products. We're going to do some cross products. We're going to multiply both sides by the 5 and then 3, and things cancel out. So 5 sine 20 degrees equals 3 sine of B. I'm going to divide both sides by 3. So I get sine of B is equal to 5 sine 20 degrees over 3. So let's just plug that in, and then we're going to have to undo this, right? So we'll show you how to undo this. This is tricky. So 5 sine 20, again, make sure you're in the right thing. We're going to divide by 3 equals, so 0.57. So sine of B equals 0.57. To undo this, we're going to do the inverse sign. So B is equal to sine inverse or arc sine of 0.57. So sine inverse is just second sine. We see it right up there. Okay, it just means we're going to undo the sine function. So 0.57 equals, and we get 34.75. So angle B is equal to 34.75. But here's the problem. Are you ready? So we got angle A, angle B, angle C. We got little a, we got little b, we got little c, right? And we've got a is equal to 20. We've got b is equal to 34.75, which means 54.75 taken up. So 180 minus 54.75, which means angle C is 125.25. Right? We know that A is 3, B is 5. We've got one more to solve, so I can do law of sines again to figure that out. But this is only one of the two solutions. Ooh, so exciting, so exciting. All right, and we're going to have to draw a picture to figure out what the other solution is. So let's go ahead and finish this up, right? So we got sine 20 over 3 is equal to sine 125.25 over C. So C is going to equal 3 times sine 125.25 over sine of 20. So 3 sine 125.25 equals divided by sine of 20 equals 7.16. Cool. So that's the third one there. And there we go. We've got one of the options. So let's draw what this looks like. Okay. And then we'll be able to figure out the second one. So we got one of the two triangles done. Now we got to get the other one. All right. So we don't know what C looks like. So we're going to do this. We're going to go angle 20 degrees up here. We've got, let's see. So if that's A is 20 and this is 3 and B is 5, we've got two options, right? It's going to go here or it's going to go here. And this is 3 and this is 3, right? So my two options are, I'm going to draw them up here, 5, oops, 20 and 3. Or we've got the same thing with 20 degrees, and we've got 5 and 3 and 20, right? So that's our other option. These are our two options from here. This one got a C of 7.16. So which one do you think it is? This one or this one? It's this one, right? This is 7.16. And then my angle that's opposite, my B, right? So this is my, let's see, B equals 5. So 34.75 is right here, 34.75, right? And then this would be 125.25. So this has to be the angle that I solved here, just based on how it looks and the fact that this is the largest side, right? So how do I find the other one? Well, thinking about this angle here, let's go over here. This angle here and this angle here, if these sides are the same, just focus on that triangle, this would and this have to be equal. So this has to be the supplementary angle to that, right? So this, for this angle, is going to be 180 minus 34.75. Okay, so 180 minus 34.75 equals 145.25. That's a lot. All right, so my second angle will be 20. My second angle B is going to be 145.25. My second angle C, I've got to, let's see, add 20 and then subtract it from 180. So I get 14.75. Cool. My A, my B, and my C are 3 and 5. What's up? In about 2 minutes. I'm almost done. Thanks. All right. So we got the 3, we got the 5. We just have to find that last thing, right? So let's go. I'm just going to go sine of 20 degrees over 3 is equal to, and we're doing this last one here, sine of 14.75 over C. So that means C is equal to 3 times sine 14.75 divided by sine of 20 degrees. All right, let's do it. So 3 sine 14.75 equals divided by sine of 20 equals, and I get 2.233. C is about equal to 2.333, 2.333, and there we go. All right, so these are our two potential triangles that would come from this scenario because of the ambiguous case. Is that a lot of work? Yes. Are you thanking your stars that in this class I'm not going to give you one of these? Yes. But it's good to know that it exists and you have the notes to be able to do it at some point if a future class asks. So that's it. We'll see ya. Bye. Bye. Maybe, maybe not. I don't know.